In this lesson, we're going to learn about data visualization and data exploration. So why visualize our data? Well, graphs and charts are incredibly powerful and very useful in being able to understand what it is that we're actually dealing with. Because there's actually only so much that you can learn from looking at a table of numbers. Very often, you want to put it up on a chart so that way you can spot problems, you can spot outliers, you can spot trends, and you can spot patterns. Pictures are incredibly informative. So let's create this chart in something called Jupyter Notebook. Head on over to a website called jupyter.org. If you scroll down here, then there's a button where it says try it in your browser. And this will take you to jupyter.org/try. I'm going to put a link to this very site in the course resources, so you'll find it there as well. Once you're here, click on Try Jupyter with Python. And after a little loading time, then you should be dropped off on a screen like this. Now, if you didn't end up on the page that I showed you just now, and instead you got this message, then you can do one of two things. Either you can skip ahead and see how we can install Jupyter, or you can wait a few minutes and just refresh. And that should drop you off somewhere like this. So why do I like Jupyter and why are we using it? Well, this is an incredible tool. It's very powerful, it's very easy to use, and it provides instant feedback when we're writing our Python code. Jupyter works on something called cells, and you can execute the code in these cells individually. Let me show you what I mean. So with this little plus sign here, you can insert new cells, and if you type something in one of these cells, say 5 plus 5, and hit Shift-Enter on your keyboard, then this cell will execute and you'll see the output below the cell. Alternatively, if you don't want to use the keyboard shortcut, there's also this Run button up here. So let me just change this to 5 plus 6 and press Run. Then you'll see this cell being executed and the output being updated. The other reason I really like Jupyter Notebook is because it's fantastic at allowing you to present information. Because the cells are actually all not created equal. Some of these cells only present you with information, like these ones, and these are so-called markdown cells. And other cells are actually cells that expect Python code, like these ones. And you can see this in the difference in the formatting. Now let me show you how to start a notebook of our own. If I click up here, where it says Jupyter, just on the logo, I could take into something that looks a little bit like Windows Explorer or Mac Finder. I've got folders and files on here, and here I can click on New and say New Notebook, and I can specify that I want a new Python 3 notebook. And this will open a new tab in my browser with a fresh notebook that we can use for this project. So let's give this notebook a name. Instead of it being called Untitled, let's call it Linear Regression. And then we'll hit Rename. And if you change tabs back to the first tab here, you can see this notebook appear in green right here. So how do we get our data from our spreadsheet into our Jupyter Notebook? Well, there's a small button here called Upload, and if you click on it, then you can upload a CSV file to Jupyter. Now, you can either download your data from the Google Sheet in a CSV or comma-separated value format, but what I'd recommend is to download the cost_revenue_clean.csv file that we've provided in the course resources. This way, we can ensure that we're all working from the same clean data and there's no accidental typos. So just select this file and hit Open, and then confirm your upload. You should then see the CSV file appear right here. So now we've uploaded it successfully. Heading back into our Jupyter Notebook, we now have to get the data from this CSV file into our notebook. In other words, we need a way of accessing the data in the notebook itself. The problem is that our notebook is currently blank. It doesn't know how to do anything yet. So we have to give our notebook some sort of functionality. And we can do this by accessing code that other people have already written and taking advantage of that. Other people's Python code is bundled up in something called a module. And in order to use a module in our notebook, we have to import this module. The first module that I'd like to introduce to you is called pandas. So if we write import pandas in this very first cell and hit Shift-Enter on our keyboard or press this little Run button, then we've accomplished just that. Now our notebook has all the functionality that the pandas module has. Pandas is one of the key modules for data science, and we will be using it a lot in this course. It's incredibly useful for manipulating and analyzing data. And the pandas module can already help us because it knows how to read CSV files. So let's use it to get the data into our Jupyter notebook. If we write pandas.read_CSV, and then we open a pair of parentheses, then we can supply the file name of our CSV file between these two single quotes. Our file name, if you recall, was cost_revenue_clean.csv. And you can see that right here. So I'm just gonna copy this and then paste it in between these two single quotes. The key thing to understand here is that we're accessing the ability to read CSV files from the pandas module using this dot notation. But now that we've read our CSV file, we need to store the data from this file somewhere. So we need some sort of object that holds on to our data, like a container. And we can create this simply by writing data equals on the left-hand side and then having pandas.readCSV on the right-hand side. What this will do is it will create an object called data, which then gets a value, the data that's contained inside the CSV file. And if we run this cell, we can actually look at it. So let's click run and then write data and then just hit run again. And here what we should see is all the data points and all the information that was previously stored inside our CSV file. The great thing about this is now we have an object in our notebook that we can use to analyze and explore our data. Let me show you what I mean. So instead of printing out all these 5,000 rows below this cell, what we can do is we can put a dot after our data object and tell it to describe itself. So with data.describe and two parentheses at the end and hitting Shift Enter, we get the following output. We get some summary statistics on the data that's in the two columns, our production budgets and our worldwide gross. We get to see how many entries were in our data frame. We get to see how many entries were in these columns. In this case, we have 5,034 entries. The reason that these numbers look a little bit funny is because they're in scientific notation. So for example, 5.034 E3 equates to 5,034. And 3.29 E7 equates to 32 million. So 3.29 E7 or 32.9 million is actually the average production budget of all the films in our dataset. And this is what we see here labeled as the mean. But not only do we get the number of entries and the average of the values, but we can also see a number of other statistics like the minimum value, the smallest value. So the smallest production budget was $1,100. And we also see the smallest amount of worldwide gross revenue, which was $2,600. So now we've got all our data in one place. We have it all stored inside an object called data. But let's separate it out. Let's separate out what we're using to make our prediction, our production budget, from what we're going to predict, namely our gross revenue. And the reason we're doing this is because we're preparing our data for the next steps. We want to be able to create some charts and we want to be able to create our linear regression. So it's going to be very, very nice to stay organized and have our features separated from our target. So now come down here to a new cell and I'm going to create two more objects. One is going to be called capital X and the other one is going to be called lowercase y. Now, our X is going to hold on to our production budgets and our Y is going to hold on to our revenue. So we're using that equals sign again, just as we did up here. So now we have to think about what should these two things be equal to? What kind of object should our X and our Y be? At this point, I'd like to introduce you to one of the main workhorses of data science, the pandas data frame. You can think of a data frame as a very powerful spreadsheet, like a spreadsheet on steroids. So the question is, how do we get hold of a pandas data frame? Well, we can come back up here, where we're importing pandas, and we can import the data frame from pandas. So from pandas, import data frame. Now, if you hit Tab on your keyboard, then Jupyter Notebook should actually autocomplete some of the code for you. That way, you won't make a typo here with, say, a lowercase f or something. Autocomplete is incredibly useful for avoiding these small mistakes. Now we can come back to our X and our Y. Here, what we're going to do is we're going to create a new data frame. And this data frame is going to contain our production budgets. So X is going to equal data frame, open parentheses, data, comma, columns is equal to square brackets. And in the single quotes, we're going to provide the column name. The column name for our X's is going to be production budget USD. So you can just copy this from the spreadsheet, or you can type it out as long as you make sure that the spelling matches exactly. And then your line of code should look like this. So what are we doing here? We're creating a new data frame from our raw data, which we've got here, and we're selecting a single column from this data, namely the production budgets. And that's how we're splitting up our data frame here for our X's. Now at this point, I'd like to throw over a challenge to you. I'd like you to pause the video and split up the data for our Y's. Can you create a data frame just like this, but instead of grabbing that first column, can you grab the other column, the worldwide gross, and then store this information as our Y? I'll give you a few seconds to pause the video and give this a go. All right, here's the solution. You can actually copy the line above and paste it below, and then just replace the column name with the column name for the worldwide gross revenue. So in this case, you need to take this column name here and add it between the single quotes inside the square brackets. Having done this, we've separated our data. We've created two new data frames, one called capital X, which holds on to our features, and one called lowercase y, which holds on to our target. So let's execute the code in the cell and see what happens. So if we click run here, then what you see is that we actually get an error. We get something that says name data frame is not defined. And the reason we're getting this error is because our notebook actually doesn't know what a data frame is. But why is that? If we go up here, we can very, very clearly see that we're importing the data frame from pandas. The reason we're getting this error is because we've modified this cell, but we actually have not run this cell yet. In other words, we have to select this cell, run the cell, and it's at this point that our notebook knows about the data frame. So if we come down here to where we're creating our X and our Y and run this cell again, this error will disappear. The code will now execute successfully. So now that we've successfully separated out our data, let's visualize it. And for that, we need some functionality from another module. That module is called matplotlib. Matplotlib has a whole bunch of graphing and plotting functionality, and this is the module that will help us create our charts. So let's import matplotlib into our notebook. Going to the very top, where we've got all our import statements nicely organized, let's add another one. Let's say import matplotlib. Now, the specific plotting functionality that we actually need is only a small part of matplotlib. And this plotting functionality is called pyplot. So if we import matplotlib.pyplot and hit Shift-Enter on our keyboard to execute this cell, then we can start creating our charts. Coming down to the bottom of our notebook, in a new cell, we can now create our first chart. Let's create a scatter plot. So let's get hold of matplotlib.pyplot.scatter, open parentheses, x, comma, y. What this line of code will do is it will create our scatter plot for us. To show our chart in our notebook, we actually have to tell matplotlib to show our plot. And we can do this with matplotlib.pyplot.show, and then parentheses at the end. Let's hit Shift-Enter and see what this looks like. After our cell executes, we should see something like this. Now, I want to do a couple of things. First off, I want to simplify our code. And second, I want to prettify our chart so that it becomes a lot more informative. The problem with the code is that it's a little bit long. If you go online and you take a look at some of the documentation, you rarely see code written like this. What people do is they shorten this bit of the code. So what we can do is we can go to our import statements at the very top, and we can create something called an alias for our pyplot. And we can do this by simply writing as plt. And this as keyword gives our pyplot this short name. So we're importing matplotlib's pyplot as plt. And this means we can come down here, and instead of writing all of this and then scatter, we just write plt.scatter. And here we just write plt.show. And just to prove that this works, I'm going to have to execute this cell first, because I've made some changes here. And then I can come down here and execute this cell. And what we should see is the same result as before. So what can we do to make this chart a lot more informative? Well, we can add a title to it, or we can add labels to the axes to make it a lot more clear what's going on. To do that, we can adopt a very, very similar approach to what we did up here. We had some sort of object, then we put a dot after it, and then we told it to do something. Up here, we were using our data object, but with our chart, we're going to use plt. So to add a title to our chart, we simply write plt.title, and then in the parentheses, we provide the title. So I'm going to call this chart film cost versus global revenue. And when I hit Shift Enter to refresh the chart, then the title will appear just above. And similarly, we can add labels to the axes. So with plt.xlabel, we can add production budget in dollars to the x-axis. And with plt.ylabel, we can add worldwide gross to the y-axis. Brilliant. Now, what else can we do? Well, first, let's make our chart larger. So if I come up here and I write plt.figure, I can change the size of our chart. And I can do that by setting the figure's figure size with fig size is equal to, and then parentheses, and I can supply a width and a height here. So I'm going to go with 10 by 6. And if I hit Shift Enter, then my chart will update and become much larger than before. And at this point, what's becoming very clear is that our y-axis and our x-axis are actually going below 0. So there's some space here to plot anything that is a negative number. But if we look up here, we can actually see that for both our production budgets and our revenue, we don't go anywhere near 0. So what we can do for our chart is we can set a range for what should be displayed on the x-axis and the y-axis. To customize our chart in this way, we would write plt.ylim, and then in the parentheses, we set a minimum and a maximum value. So for our y, I think we can go between 0 and 3 billion, just so that we capture this data point up here in the top right corner. So I'll add plt.ylim, and then in the parentheses, 0, 3, and then billion. Billion has 9 zeros, I believe. So 1, 2, 3, 6, 7, 8, 9. Let's hit Shift Enter on the cell and refresh that chart. And let's take a look at our changes. Now that empty space below has disappeared. So let's do the same thing for the x-axis. And I actually want to leave that over to you as a challenge. See if you can figure out how to add some code to the cell to set the limit on the x-axis to have a minimum value of 0, but a maximum value of 450 million. That way, when you refresh, you should get rid of this white space here, and we should see our chart much more clearly. I'll give you a few seconds to pause the video before I show you the solution. Ready? Here we go. It's very similar to what we did with our y-axis. In this case, we have to modify one thing in our code. Instead of ylim, we're going to go for xlim. And instead of 3 billion, we're going to go for 450 million, which is 450 followed by 6 zeros. If I hit Shift Enter on my cell, then I should see my chart update like so. But we can actually improve the styling a little bit further. One thing we can do, for example, is we can add transparency to our dots here. So we can go to our scatter plot, and similar to what we did here with setting the figure size for the figure, so the overall size of the chart, we can actually set the transparency for the dots in the scatter plot. And we can do that by putting a comma after the y and setting something called the alpha value. So by setting alpha equal to 0.3 and hitting Shift Enter, then we'll see that our dots have become a lot more transparent. And this will give us a good appreciation for the number of data points that we have in certain areas of the chart. So down here, we have loads and loads of movies and loads of data points. And as we go to the top right, there's fewer and fewer films. So where are we at now? At this point, we've done some excellent work visualizing our data. And this has helped us spot some of the clear outliers in the film world. For example, this film right here has had an enormous production cost and also made a lot of money. This movie is called Avatar, by the way, if you're wondering. And looking at this chart, you can see just how out of the ordinary this film was relative to other movies. But there are also some films that have made very, very little money but cost a fortune. And these films are down here. That said, what's very clear from this chart is that most films are actually smaller productions, less than, say, 1 million. And we can see that from this very dense cloud of data points in the lower left-hand corner. Looking at this chart, we can also start to understand more about the relationship or the potential relationship between movie budgets and movie revenue. Because there indeed seems to be some sort of upward trend that's visible in the chart, and higher budget films do indeed appear to have higher revenue. But how much higher exactly? And how strong is the relationship? To answer these questions, we will need to turn to our linear regression. Our linear regression can help us quantify this relationship. But before we do that in the next lesson, let's save our work. We've written quite a lot of code and it would be a shame to lose it. And I can tell you one thing, trying Jupyter online is prone to get you disconnected if you leave it alone for too long. So go to File and then go to Download as Jupyter Notebook. And this is the .ipynb extension. That way, if you do get disconnected, your work is saved. And you can come back here to upload your Jupyter Notebook if you need to continue where you left off. I'll see you in the next lesson.